We're 3D printing. So use an OBJ or STL file. What you do is you go tell your Onshape document, and in the parts list, on the bottom left, you can click on a part. So you right click the part that you want to export or that you want to 3D print, and then you export it. Yeah, and then format OBJ STL. Just go with OBJ because STL actually has some other thing with it that you need to set the units. It can be kind of weird. So go with OBJ.
Go with OBJ, guys.
Yeah.
You hear that? Export with OBJ.
Yeah. Unless you want to like go and do like a different measurement system. So OBJ, resolution, fine, options, download, yeah. Alright, export. Okay, now it's gonna be in your file explorer. So it actually downloaded as a zip. Okay, right click. So in your file explorer, you'll see under the downloads folder, you'll see Part Studio, or like whatever your name of the Part Studio is. And it's a zip file. So you have to right click it and then you have to extract.
I don't think that's for Mac.
I think you do have to.
There's zip files. Why don't you just drag it in?
You just drag
You
it
can
in.
just drag it in? Okay, that's
straight
cool.
onto it.
Alright, then don't pay attention to this. Alright. Now we have our part studio.mtl, and that's not important. But if we open this and then we make the window smaller. If we open back our Cura and we make our window smaller, and then we go back to our file explorer, and we can like drag it over.
On Mac.
Yeah, your Finder.
Or your exported.
Yeah, and you can just you can drag in your part.
Yeah.
Yeah.
Drag in the thing that says .obj, whatever it is, .obj.
Alternatively, you can click this folder button in the top left, and that also will let you like bring in some stuff.
Do we just drag it into
Do we do the one that's the zip?
Sometimes, alright, listen up. Sometimes you're gonna import your part and it's gonna like be in a really weird angle. Or it's gonna be like vertical. It's gonna be vertical like this.
backspace nowhere?
Right? And that's gonna suck if you try to print it like that. So you can press this lay flat button if you click this rotate tool. First click on your object and then click on this like arrow going in a circle on the left, and then you can click lay. Oh wait, it's already laying flat. You can click select face to align with build plate tool, and then you can just click on the face and it'll align that face with the build plate. So that's pretty cool.
Do we want to print it with a skirt?
Like you don't need to. Maybe if you're at home and your printer has really bad bed infusion, like, go ahead. And remember, 3D printing is like, I didn't tell you this, but 3D printing is like cooking, so if something goes wrong, just like change your settings a little bit, and maybe it'll work.
Or you can just use
How do I get support?
Always fixes it.
Nah. If you press slice, it should add support. Actually, my settings don't have it. So, once you're ready to slice your print, just click the slice button over here. Right now it says save to disk. Wait, let me just like move it around a little bit. Okay, it'll say slice, and you click slice, and it'll process your model into G code. And did it add supports for you when you press slice? It should if your support settings are enabled. Mine are off, but I didn't tell you guys to turn it off, so it should be enabled.
It tells me you can't save it on disk. It's an error.
Like anything changed? So you have 3 tabs on the top. Prepare, preview, and monitor. You don't really use the monitor tab. So go to preview, and you can actually see like what happens on each layer. So, like, so this thing on the side lets you adjust like what layer you want to see or what layers you want to see.
Justin, can you just
Oh yeah, true. Okay, yeah, so this thing on the side lets you see your layers once you're in the preview tab. The preview tab is, you can go to it from the top middle, right? And now you can see your, you can see like what the printer is actually gonna do. So if you drag this like thing down, you can actually see the layers, which is pretty cool.
I love those.
Yeah, I love it. It looks pretty satisfying. Like you can even zoom in and see each individual line that it prints. How do I explain it?
You got that? Did you remove like the support or whatever?
Oh yeah.
Well, you might print. Are you gonna?
Cool. Everything looks ready. You've confirmed in the preview tab that everything works, and you have your supports if you want it. Save to disk. Okay. And it should. Okay, you'll see like a different screen because you're on your Mac.
Wait,
And-
do I save to disk?
And it'll say, so name your file, and also it'll say save to where. It'll say, it'll say save to where, or like there's a tab that says where, and it's gonna say Macintosh HD. And you don't want to download it to Macintosh HD because that's actually like on your
It's like
on
your
like
hard
the
drive,
total
whatever.
computer's file system, yeah. And you'll need the admin password to.
Just put it to downloads or
Yeah.
desktop.
So save it to your desktop or something, or you can make a new folder on your desktop and save. So here I have my desktop G code folder. Pretty cool. With the secret sauce. All right, this is the stuff they don't tell you until they tell you it.
Did I lose it the hard way?
Did I lose? What did we go over? Okay, so we went over everything here. Like, okay, yeah, we went over everything. Okay, materials and temperatures. This is nonsense because we're going really fast. This is not nonsense because we haven't tried printing this yet. Okay. So, yeah, this is what you want to see. I was gonna put like a meme there, but Tyler advised me against it. So yeah, if you go really fast, you want to run it a little bit hotter. Okay, next. All right, we're running low on time, I feel like. All right, consider the following. All right, you print a part. It does something. Okay. Okay. Your 3D printed part. This is what it looks like. Okay. So this is what the outside looks like. It's a bunch of layers, right? And the inside is also like a bunch of layers, but it's a pattern. Okay. Here we go.
Go over changing pattern.
Oh yeah, I should go over that. And to change your pattern, you just in your software settings, you search up infill, and that will change the inside. All right.
Like it's like a drop down.
Yeah. Okay. So this is like a set of rules to cook up a good 3D print.
A strong 30.
Yeah. So this is a set of rules to cook up a strong design. So your 3D printed part should adhere with the print bed, unless I'll get to that. Okay. It should always adhere. It should have a face to adhere. Unless. Okay. A layer must have some material below to print properly. It's pretty self-explanatory. All right. The printer can bridge. All right. So if you have like a section of air, but it's printing off like two like stubs, you can print between those. That you can test on your own with your own files. If you search up like temperature tower, you should be able to print that. 3D printers hate overhangs of more than 45 degrees with the vertical. But we can handle like, maybe not 70, like maybe 65 degrees. But I'm pretty sure my my pulley has a 70-degree angle and it still works. Okay, sharp corners distribute stress more, like it distributes stress worse than round corners. Okay, that's pretty important because if you want something really strong, and also parts that fit into other parts need at least like a 0.1 millimeter tolerance. Okay.
That's really important.
Yeah, that's important because last year I was trying to print like witches and I needed to like post-process them for like an hour.
Yeah, files.
To,
Where
yeah.
would you change the tolerance? Would you change it in on-shape or would you change it in the
Oh, yeah, and to change the tolerance, you need to physically, you need to change your design in the CAD software. So, say you have a circle that is like a diameter of 3 millimeters, and you want to fit it into another like thing that's also a diameter of 3 millimeters. You actually need to change the circle, one of the circles, to be like 2.99 millimeters or 2.9 millimeters. Okay, here we go. Supports. Just disable it. Like with the stuff we're printing, like you don't really need supports. Like we're not going to be needing to print extremely fancy geometry. Like if you need to enable supports, like you can, but you honestly just want to go without it because they take up a lot of time. The supports taking up material doesn't really matter for us, but like the time part really does matter. So, and also after you remove your supports, like our printer is fine with it, but like after you remove it, like it'll often leave like little bits of support material on your print surface, and sometimes you just don't want that. Okay. Nice. And you can refer back to this, but basically it takes extra time, which is the important part. So if you need supports, how do you make them less annoying? You can make your supports less dense. You can make them thinner. And you can also change it to a different pattern. Or you can use these fancy new tree supports, the secret sauce of, of supports. I never really tried using tree supports, but apparently they're like 20% faster and they save like 10% material. So yeah, that's pretty cool. And tree supports are like an acacia tree from Minecraft. And if you were trying to build like a house, say your supports are like an acacia tree in Minecraft. Okay, this is a waste of time. Okay. Do I need supports? Do you need supports? Well, let's find out. You can just CAD your own support structure because you're cool, right? You're cool like that. You're smart. You can make your own supports. Why do you need a computer to do it? The computer probably will do it wrong. Like it makes supports inside random places. All right. You can just angle your whole model in the slicer to remove the need for supports. I'll show you an example. All right. You want to utilize bridging? Okay, it's pretty cool. So this is kind of hard to explain, but if you 3D print something with like an arch, it'll actually be worse to print it with an arch than to just bridge it at a 90 degree. So if you print something at an arch, it'll go like, the layers will look like this. Here's a marker. The layer will look like this, right? So it'll go like this. This is the wall, and then it'll start arching, right? But what is it doing? What is it doing here? There's overhang, right? And this section of plastic right here is not being supported by anything. And then let's go even closer to like the top view. And this is what the section looks like from the top view. And this section of plastic is not even like supported by anything. So it's gonna be worse quality than if you just like, than if you have like this. If you have like this. If these are all like the same width, and then it just goes across. Because what's it doing is it's printing this, say this is the top also. It's gonna bridge and it's not gonna turn in midair. So everything's gonna be more stable. So you don't wanna have arches because yeah, it's worse. Okay. So include chamfers. Chamfers are like chamfers are like arches, but instead of like having like a curve, a nice like thing here, it's just 45 degrees. The chamfer is just 45 degrees. And usually you also don't want a chamfer like this, but you can put it on your on like the bottom parts to make it more stable. But that's like kind of a design thing. If you need to have like space there, then you don't need a chamfer. Okay. When you design, think about how you can reduce the need for support. Like, say you have like an overhang, maybe you can like design it so that it's printed upside down, so you don't need an overhang. That's more of like an afterthought though, because the design matters, not like the way you print it, right? The design comes first. And then our team's 3D printer is goated. You probably won't need supports. All right, so let's quick recap. Which one's better, this or this? Which one's better to print, this or this?
Bottom.
The bottom. Yeah, because what it's doing is making these, what it's doing here is it's making a bunch of these where like the edge isn't supported by anything. It'll turn in midair, and that will suck. Okay, and this is an example of like adding in your own supports. So these are auto-generated supports. Like, what is this? What is this? I don't know. It just sucks, and you kind of don't want that. So this guy like took this design and just added like a cylinder here. Like, he added a hollow cylinder here and then a hollow cylinder on the outside. And that's his CADed supports. It's super simple. So if your auto-generated supports like don't look good, just make your own. Okay, we kind of already went over this. Okay, we kind of already went over how to print strong parts, but we're going even stronger, right? So now your part's going to be experiencing forces. So you need to make sure that the forces are going in the same direction as the layer lines.
Like
right?
grain of wood.
Yeah, exactly. Like here we have this picture. This guy's spending a lot of effort, like hacking away at a tree because he's going like against the grains.